Hello everyone, and welcome to Island Technology presentation on DrayTek routers and NBN in Australia. My name is Edward Roy, and I am a network engineer at Island Technology, together with Roy Panetta, who is the technical manager at Island Technology. We will give you an overview NBN in Australia and connectivity solution from DrayTek that will meet network requirements for both businesses and home users. I will now pass you to Roy to tell more about DrayTek and NBN in Australia.
Hello everybody, my name is Roy Panetta. What we'll do, we'll start by we look at a number of topics today. And first we'll look at what is NBN in Australia. Then we'll look at the multi-technology mix for NBN that is currently being rolled out. And I will also briefly show you which DrayTek routers are NBN ready. And then next we'll look at NBN's fibre to the node and fibre to the basement network, as well as some of the latest developments. So first we'll look at what is NBN. So NBN in Australia is known as National Broadband Network, which was first announced by the Australian government in April 2009. This is a government-funded national data network which aims to deliver up to 100 megabits per second internet downstream speeds to all Australian households and businesses by 2021. NBN was set up by the Australian government as the body to design, build and operate the NBN. The main reason for the NBN was that the existing copper cable telephony infrastructure was approaching end of life and required substantial replacement or remediation. It was also not able to meet the high speed requirements for business users. It was proposed at the time to roll out optic fibre to 93% of premises, which is fibre to the premises, by 2021, with construction beginning with a trial rollout in Tasmania in July 2010. However, with the subsequent change of government, a multi-technology mix was implemented to speed up the deployment of NBN using existing infrastructure, and at the same time hoping to reduce overall costs. The multi-technology mix involved using fibre to the premises, fibre to the node, fibre to the building architectures, as well as existing hybrid fibre Coax, or it's also known as HFC networks, such as those used by Telstra and Optus. Regional and remote areas will be serviced by either satellite or 4G LTE fixed wireless. So I'll talk more about these technologies later. So this diagram shows the map of Australia with some numbers on it, and just gives an indication of the NBN rollout as of September 2016 and July 2017. So the July, that's last month, was shown in red there, and as you can see, almost 6 million premises that are now ready for NBN service. So the NBN target was to reach 12 million premises by 2020. In December 2016, there were over 3.5 million premises covered, and now in July this year, there's 6 million covered. So this means that the rollout has reached about 50% of the targeted total. And this information is available on the NBN website if you wish to know a bit more. So now we'll look at in more detail at the technology involved in the multi-technology mix for NBN. So as I mentioned earlier, the multi-technology mix was adopted by the Liberal government due to the large areas to be covered in Australia, with many areas having a small population. It was necessary to have a variety of technologies to provide broadband access. So most households only need internet speeds of around 20 or 30 megabits per second, but cannot wait indefinitely for fast Ethernet. So the multi-technology mix helps to speed up the deployment. And the multi-technology mix uses a variety of technologies to provide broadband access. In this way, it allows a cost reduction from approximately 50 billion to about 30 billion, and a couple of years faster deployment to most places in Australia. And this table, I don't know if you can see properly, but it just shows the distribution of the technology types for NBN access. And the fibre to the premises is about 25%, and fibre to the node and fibre to the basement is the largest proportion, which is about 40%. And these use VDSL2 with roadside or basement cabinets, or cabinets for VDSL DSLAMs. And DrayTek broadband routers are well suited for each of these technology types. And the amount of copper cabling required for each technology type is shown in this diagram. The fibre to the premises, shown as FTTH at the bottom of the diagram, does not require copper cabling. Fibre to the basement is used in high-rise apartment buildings where the copper cabling is between floors in the building. Fibre to the node, shown at the top of the diagram, can have up to 300 meters of copper cabling to provide a maximum VDSL speed. So I'll quickly go over each of these technologies. So let's bring the slide up. So the first one we look at is the fibre to the premises. Here we have the optic fibre connected between the NBN point of interconnection and the NBN utility box attached to outside the premises. This is then connected to the NBN connection box shown in at the bottom of this slide. So just a little photo down the bottom there. And this box is usually installed inside the building. So it has an Ethernet WAN socket, which provides the interface to connect to a broadband router. And the next one is the fibre to the premises. The NBN will install a NBN connection box inside the premises that terminates the optic fibre and provides data outlets labelled Uni-D ports. So this will be the box that goes inside the house. The connection box also has 2 Uni-V ports for connection to a phone service. And I think a lot of the ISPs, they use the Uni-V ports now. So as part of the NBN rollout, existing landline phone services will be disconnected, so VoIP will need to be used. The NBN connection box does have 2 Uni-V ports to connect to analog phones to use the VoIP service. So as I mentioned, some ISPs now supply their own VoIP router to provide phone services, so they do not use the Uni-V ports on the NBN connection box. And in this diagram, it just shows the NBN connection box with the cover removed. And here we have the optic fibre termination on the right-hand side. It's sort of coiled up that green fibre. And the data cable shown in blue connected to the Uni-D port on the bottom. And here we have a diagram of the fibre to the premises installation, where we have the NBN utility box outside the building, where the optic fibre is fed to inside the building. And inside the building we have the NBN connection box and the optional power supply with a battery backup. So all mains powered equipment connected to the NBN network will need to have its own separate battery backup to work in a power outage. The battery backup power provides up to about 5 hours runtime, and is recommended if you're going to be using phone services. In multi-dwelling installations, such as in high-rise buildings, we have optic fibre run to the basement of the building and then to each apartment through the floors. And you can see in the photos there, this can only be done in newly constructed buildings. So in older buildings with existing copper cabling between floors, this method will be too costly. So in this situation, the preferred method is to use fibre to the basement with VDSL2 services being run over the existing copper cabling. And here we have a picture of the NBN connection box installed in a unit within a multi-dwelling building. So to the right, we have a close-up picture of the NBN connection box with the cover removed, showing the fibre terminations. So the routers that are suitable for the fibre to the premises installation are shown here. These are all the broadband routers and a couple of XDSL routers. So each of these has got at least one Ethernet WAN interface, and the VIGA 2760 can be configured so that the LAN port 4 will be an Ethernet WAN connection. So it can also be used for this installation. So the most suitable router for an installation will depend on features required as well as speed requirements. So another technology used is fibre to the node. And here optic fibre is installed from the NBN point of interconnect to a node, which is usually a roadside cabinet, shown here, which is a little photo down the bottom. And these are usually those green boxes you see, on the street. And from here, the existing copper cabling is utilised to provide VDSL2 services to the premises. The distance between the node and the premises is usually about 300 metres to ensure that the required NBN speeds are provided. So at a distance of about 1.6 kilometres, the performance will be the same as an ADSL2 connection. So I suppose I try to aim to keep the length of cabling, less than 1.6 kilometres. So for high-rise apartment buildings, which already have copper telephone cabling installed throughout the building, the optic fibre is installed to the basement of the building. This is known as fibre to the basement. It is also referred to as fibre to the building. For most existing high-rise buildings, this is the quickest way, if not the only way, to upgrade fast Ethernet from all copper ADSL to mostly fibre, but little copper and VDSL. And a VDSL DSLAM is installed in the basement of the building, and this provides VDSL services to the tenants through the existing copper cabling within the building. NBN is now mainly installing a fibre to the node and fibre to the basement to speed up the deployment. So here, optic fibre runs to roadside cabinets, which we've got pictured here, or in buildings with copper cables that's used for the last leg, which can be up to 1 kilometre. And this type of installation covers about 40% of all premises. So in the picture we've got shown here, on the left we have a typical roadside fibre to the node cabinet, and on the right you can just see that you can just notice it houses about a VDSL DSLAM, and this supports a maximum of 1,536 homes with up to 4 line cards and 384 circuits each. So the photo's a bit small because it's a rack-mounted unit with with line cards. And for remote areas where it's not feasible to install optic fibre, NBN provides either fixed wireless or satellite technology solutions. For fixed wireless solutions, NBN deploys a 4G LTE wireless network covering approximately 4% of the population outside the fibre footprint. The 2.3 gigahertz and 3.4 gigahertz spectrums, or wireless spectrums, which are also known as band 40 and 42, are used to deliver these services to premises fitted with appropriate antenna and network termination device. So the diagram at the bottom of the page shows a typical installation for a fixed wireless internet connection, with an outdoor antenna connected to a wall socket and a network termination unit attached to the computers in the premises. And here we have a picture showing the type of outdoor antenna that's used for fixed wireless installations. That's on the left, and then the network termination unit that's installed inside the building. That's the photo on the right-hand side there. And for remote locations which are outside the reach of other technologies, including Christmas Island and all the way to Lord Howe and Norfolk Islands, NBN is providing satellite service known as SkyMuster. So SkyMuster was launched in October 2015 and became operational in April 2016. These are the 2 satellites used, and they concentrate the beam to a specific geographical areas. Each satellite provides a bandwidth of about 80 gigabits per second and are expected to provide high-speed fibre broadband to at least about 400,000 Australian homes and businesses in rural and remote Australia. So take a look at the next slide, and here we have some images that are of the type of equipment involved for satellite services. First, the data stream is transmitted to the satellite from either the base station or roof-type satellites dish, and then the overhead satellite retransmits the data stream to the destination satellite dish. And the last technology we'll look at is for the multi-technology mix is a hybrid fibre coax. It's also known as HFC cabling. Now, this cable is owned by Telstra and Optus and was scheduled to be shut down. For example, the Foxtel coax cabling used by Telstra and is now used for the NBN connections. And this has been done mainly to speed up the NBN rollout to deliver NBN services. And the diagram towards the bottom just shows how NBN delivers its service from the NBN point of interconnect to the NBN connection box at the premises. For these connections, a DrayTek broadband router with a gigabit Ethernet WAN interface will be suitable. These will be similar to the routers we mentioned for fibre to the premises installations. So NBN has ditched plans to use the bulk of the Optus hybrid fibre Coax network due to the cost of upgrading this network. So instead, they deploy fibre to the distribution point to around 700,000 premises nationwide. And this diagram just shows the equipment used for HFC connections. So here you've got an NBN utility box installed outside the premises. And for installations with an existing pay TV or cable internet service, a splitter will be connected to the wall socket to allow connections up to, for existing services. And here we just have a typical modem used by some ISPs for the HFC connections. So it's just basically just a modem, like a coax cable modem with an Ethernet outlet where you plug your router into. And HFC installations will provide the same speed offerings as for fibre to the premises technology. And these are 100/40, 50/20, 25/5, and 12/1 megabits per second. We will now look at power issues with NBN and data disruption during a blackout. It should be noted that equipment connected over the NBN will not work during a power blackout. Also, telephone services are no longer powered from the exchange, so you will need to consider using battery backup for NBN VoIP services or use mobile phones as a backup. I will quickly go through how each technology used in the NBN multi-technology mix is affected by power loss. For fibre to the premises, NBN do supply an optional battery backup unit to power the equipment. This provides up to 5 hours runtime. The unit has a sealed lead acid battery that will need to be replaced from time to time when indicated by the status indicator in the unit. For fibre to the node, the roadside cabinet does house backup batteries that provides up to 8 hours runtime. However, in the premises, you will need backup power for phone and network equipment. So you can consider connecting the equipment to a UPS, which can be purchased from most electronic stores. Finally, for HFC, fixed wireless and satellite connections, landline phones and internet services, these won't operate during a power outage. So you will need to consider installing a UPS to power your equipment. Also, you can keep a charged mobile phone for emergency phone needs. DrayTek have a number of routers suitable for NBN installations. DrayTek has a solution for all NBN technology types. Here we have broadband routers, which are suitable for fibre to the premises, fixed wireless or HFC installations, which require an Ethernet WAN connection. For VDSL2 installations, DrayTek have 4 routers shown here. These are the Viga 2860, Viga 2760, Viga 130, and the Viga BX2000 IP PBX. The ISPs use various configurations on the network. These can be VLAN tagging, MAC address binding, PPPoE authentication, and DHCP. We have a number of application notes to cover various service providers in our knowledge base at the link shown on this page. I would like to show you a video on DrayTek VDSL solutions to give you a better understanding of what DrayTek has to offer. The video is available on the YouTube link shown on this page here. Welcome to DrayTek Australia and New Zealand. Very high-speed VDSL has been introduced globally over the past few years. VDSL, very high-speed digital subscriber line, is deployed over ordinary telephone lines, similarly to, but is much faster than ADSL. Although it is available throughout New Zealand, currently as of 2014, it is not yet widely available in Australia. VDSL2 is expected to become one of the main alternatives for the aging ADSL2 Plus connections. It offers faster speeds than ADSL, with a theoretical maximum download speed of 250 megabits per second at the source 100 megabits per second at a distance of 0.5 kilometers and 50 megabits per second at 1 kilometer from the exchange. The download speed becomes comparable to ADSL2 plus speeds at 1.6 kilometers from the exchange. Therefore, VDSL2 is most suited for installations where there's fibre to the node or fibre to the basement, connections to a terminating point, and where the target homes or units are within 1.6 kilometres from the equipment room. For instance, in some existing high-rise apartment buildings where it is difficult to run optic fibre cables to all units, fibre to the basement can be installed incorporating existing phone lines to each unit to provide high-speed VDSL2 connections. In this scenario, appropriate VDSL DSLAM equipment will need to be installed. The increased bandwidth offered by VDSL2 means that transmission of high-quality video, such as high-definition television, from the internet will be easily achievable. DrayTek has a range of VDSL2 routers to suit every customer requirement. These routers range from the low-cost Viga 130, the single WAN Viga 2760, to the business-grade triple WAN Viga 2860. These routers are backward compatible with ADSL2+, so they can be used on existing ADSL2+ connections and changed to VDSL2 connection when it becomes available. I've given you a brief overview of the VDSL2 solutions from DrayTek. In our next video, I will describe in more detail VDSL router solutions from DrayTek. More details are available from our website at www.draytek.com.au, or for more information, send an email to sales@draytek.com.au. Thank you for watching.
I hope that you found the video informative. Now we will look at NBN's fibre to the node and fibre to the basement network. NBN Co. has produced a technical specification document covering fibre to the basement and fibre to the node services. This document lists the technical requirements for attached VDSL equipment. DrayTek VDSL routers meet most of the requirements for connection to the NBN. The exception is for one item listed in the document, which refers to a requirement for future-proofing and is not mandatory at the moment, since it is not supported by any other CP vendors. NBN code does not allow CP vendors to register CP devices, so registration of CP devices with NBN code is left to individual RSPs. The NBN network has adopted the ALU, that's the Alcatel-Lucent DSLAM, which uses their Broadcom chipset. Recently, as a result of ILAN technology promoting NBN solutions, NBN test engineers have chosen the Viga 2760 router to test compatibility with the Intel Lantec chipset-based routers. This has resulted in improvements to DrayTek routers firmware to ensure that they fully comply with NBN technical requirements. I will briefly go over some of the developments with DrayTek in relation to the NBN. DrayTek's VDSL2 products, which are the Viga 2860, Viga 2760 and Viga 130, they now conform to the NBN specifications. As a result of ILAN technology, is talking to key RSP, that's the NBN retail service providers, to consider DrayTek products for their customers. One RSP has already registered the Viga 2860 router with NBN Co. One step we have taken to provide better experience for customers is to ship DrayTek VDSL routers with VDSL2 vectoring firmware pre-installed as standard. This has reduced support issues with customers connecting to VDSL2 networks. This is the end of our presentation today. The messages to take away from today's presentation are that NBN is Australia's broadband building program. The multi-technology approach was adopted by the NBN to speed up the NBN and NBN's fibre to the node and fibre to the basement, which are VDSL2 installations, comprise about 40% of NBN installations. And firmware improvements in the Viga 2760, 2860 and Viga 130 ensure that NBN standards are met. I hope that you found the information presented today to be useful. More information is available on our website at www.draytek.com.au. For product information, you can send an email to sales@draytek.com.au.